Hey there guys, this is Don from Prana-Tech. Today's video I'm going to show you my new 20 volt Dewalt powered welding positioner. It's cordless and you can take it anywhere, set it up outside, wherever you're welding without having to have cords. It's variable speed and it's a great addition and something that I really wanted for a long time to help me with my fabrication. Alright, so let's get to it. I'll show you how I built this and go through all the basic steps I did, and I'll show you how it works. Alright, so when you get one of these 4-inch rotary tables, this is what it looks like when it comes. It has a standard handle that rotates the rotary table, and it has a precision vernier scale on the table as well as the handle, so you can precisely use it in a machining fashion. But one of the reasons I wanted to use a rotary table is that occasionally I do have use for a rotary table on my milling machine. So one of the motivations I had is to get the rotary table, be able to use it the majority of the time as a welding positioner, and also if I ever need to, convert it back to a rotary table for machining on my mill. It's also one of the quickest ways to make a welding positioner. All the mechanism is there, the 90 degree, the precision rotation, the bearings, everything's already there built, but you do have to take it apart. And the way this one comes, it does have a gear on the hand wheel, and you could use this, and I believe the company, if I remember right, sells a kit for hooking up a CNC servo motor that bolt right onto this, and it adds quite a bit more cost to the whole setup. So what I wanted to do is just get this, take it apart, and take the hand wheel off. And I have to say that the inspiration for this came from Aaron at 6061. He basically did the exact same thing. He used this table and he basically mounted a 6mm stud after taking the hand wheel off and mounted his variable speed drill to it, and that's how he uses it. But what I wanted to do is be able to have repeatable speeds, adjustable variable speed motor, and be able to just set it, you know, however many inches per minute that I know, and I can save my settings and dial it in. That's why my build's going to be a little bit different, a little more complex, obviously, because he just basically took the hand wheel off, went to town, and started welding with it. Mine's going to use a DC gear motor to run this, and but what we need to do first is take off some of the parts. One of them is these two lockdown. So what we're going to do is take these off because we're not going to need these. Alright, next thing we have to do is remove the hand wheel. This is just held on by one Allen screw. Take that out. It does have a machined washer, so save these because we're going to use those. And then basically it's just a keyed shaft that this slides onto. Alright, so once you take your hand wheel assembly off, you are left with the shaft. One of the things you want to be careful as you're taking this off is that it is a keyed shaft, and there's just a little tiny keyway piece that just slips in right there. And so make sure you don't lose that. I'm just going to put mine in a baggie. And then what I did is I just put it inside the hand wheel assembly. The first thing I had to do was build a mount for my motor. What I ended up with is this motor, and it is a Pittman low cog. This is a great motor, super high quality, and these are usually $150 to $160 motors if you can find them online, which this one is still available right now, and I did find it online in a couple places, but I got this off eBay. The guy's selling them for $40 and they're brand new. This is a 200 RPM gear motor. It's got a 1/4 inch shaft and it's got way more torque than this little project needs. And so this is going to get mounted on the back side right here. So what I needed next was a mount to these 3 holes, and also have a little bit of offset because this face is set back from where this is, so I needed to move the motor up far enough so that I could get a pulley lined up with it correctly. So what I did is I took some aluminum angle plate and basically bored out the hole in the center. It's just 1 inch by 2 inch, and I bored a hole through the center of it, and then I cut off another piece and bored a hole that fit the motor. And that way, by having the 2 offsets, I built a mount that basically offsets about, it's a little bit more than ½ inch. It's probably about 5/8 total. So what this does is I basically just adjusted it till I got it where I wanted, and then ran a bead across, and then I ran a couple of pieces up the side here just to give it some stiffness so that it didn't flex, because actually it did flex a little too much. So this mounts on here like that, slips over, and then the 3 screws go in and hold it to the mount, or to the table. So I also elongated, I made this hole a little oversized, and I elongated the screw holes so that I have a little bit of adjustment to tighten up the belt as it stretches over time. And so what I used for the transmission is these pulleys for 3D printers. These are GT2 or 2GT geared pulleys, and they use a geared belt. So these are metric, but you can get these. This one is 1/4 inch, so it's 6.35 millimeter, and so I did find one that actually just slipped on right onto the motor. So that one I didn't have to bore out. This one came 8 millimeter. I just bored it out to 11.5 millimeter. So you can see it has 2 set screws that just hold it in place. One I put on the flat, one I put on the round side, and that holds it in place. So those are the 2 pulleys I'm using. I bought basically a whole assortment. They sell them on Amazon. They sell like different assortment lengths from, I think, maybe 100 millimeter all the way up to 600 or 700 millimeter in the same bag. And so I just bought one of those because I didn't know what the spacing was going to come out like. So I basically built it so that it would work with this belt. And so as I got this all going, I adjusted everything so that it would work with the 200 millimeter belt. All right, let me screw this together and we'll show you what it looks like when it's all set up. All right, the other parts that I'm using in this build, I have a forward and reverse switch. That way I can make it go forward or reverse, obviously. I have a Dewalt battery mount, so I can slide in my 20-volt batteries and power the whole thing. That way it's completely cordless. And then I also have the PWM motor speed control. Right now I'm just going to hook it up and do a little test run. All right, now that I have everything hooked up, I'm going to run a test. Got the battery holder right here. Just going to plug in the one of my standard 20-volt Dewalt batteries. And you'll see that it's set at 88 right now. If you press the button, it slowly comes up to speed so it doesn't shock load the system. And it's completely adjustable up to 100%. I can slow it way down so I can go as slow as I want. Okay. All right. So now what I'm going to do is I'm going to build about a 3.5 inch box on the bottom of it, and that way my control and everything can mount into the box sides, and it'll be elevated a little bit, but that will actually help in a lot of cases, because right now when I go to tilt, it limits me down to 3 or 4 inches of pipe size. But if I raise this up, I actually am planning on putting a larger plate so that I can do larger diameter projects. So this will allow me to have it used in the horizontal position or the vertical and still be able to retain larger pieces onto the face of it. All right, so I went ahead and cut out my pieces of aluminum. And so this is what the bottom looks like. So I've cut out all my plates, and I even bored a 5/16 hole through the bottom, because I'm going to have my wires for my motor thread in more central to the unit, closer to the pivot line on the side here. That way, as I tilt it up and down, it doesn't have to have a big long cord that is in the way. This way it'll all be tucked in and come in through the box, through here into where the control mechanism is underneath. So one nice thing is it has 2 locator notches on the bottom, and that's usually for setting it up on a milling machine. They make blocks that bolt into here that align on the slots in the table on a milling machine. But what I did is I just made a couple of spacers so that when I bolt down my plate here, this way it'll pull down onto a solid surface. Otherwise you risk the chance of it pulling down and warping the plate. Alright, I've just got a couple of 1/4-20 screws. They're going to hold the box to the base of it. Once it's sitting on it, there's not a lot of movement or tension on it. This thing is fairly beefy since it's made out of cast iron. So once it's sitting on it, it's not going anywhere. All right, so basically all I did was cut out some plates, 1 for each end and 1 for each side. I did already cut out the switch plate, which this is going to go on the side like that, and this will hold the variable speed, and it'll hold the forward and reverse switch. All right, so as you can see, I've got a bunch of welding to do to get this all set up. So I'm going to get set up to weld, and I'll get this thing put together. Alright, so I've got the box all tacked up, all corners and all sides ready to go, so I'm just going to weld it up. I'll do all the welding, and when I get done, I'll show you what it looks like. But first I'm going to speed this up so you don't have to sit through all of the welding scenes. Alright, so here's some of the welds on the box. Just thought I'd show them to you. just before I polish them out, because I'm going to grind them all off and make the box have just rounded edges. Alright, so you can see that I've got all the welds polished off, and I put a brush finish on the box. I've also drilled and tapped it for the mounting of the battery holder right here. This will hold the Dewalt battery. I've put some stainless handles on each end to make this a lot easier to pick up and move around. It's kind of awkward the way it is, and I keep wanting to pick it up by the motor, which isn't good for the mount. So I've also drilled a hole for the wires for the battery box. I've got a hole here for the foot switch. Alright, I've also got this end all polished and ready to go, so that all I have to do is mount the little speed control. And I've also got my forward and reverse switch all wired up. And that's about it. I just need to get inside, get these things mounted, and get inside and wire everything up. Alright. Okay, so I've got the controls hooked up. I've got the main control board here. I've got the forward reverse switch wired in. I've got the foot switch wired in, and I've got the battery holder right here all wired in. So it's basically all wired. I've got enough play up here that I can tilt it, and it's right on the pivot point, so I don't have any pinching on the wires or stretching, pulling on it. If you hook it up, slide in your battery, the unit will display that it's got power, and you can dial in whatever speed that you want. One of the main things I really like about this is that I can do repeatability. I can make sure that, you know, if I get a setting I like, write it down and be able to reproduce it any other time that I want to. And after a while, I believe I'll get them memorized and have a really good idea for thickness and type of material, what I'm going to need. But the way it's set up, I can hit forward or reverse, and then when I'm ready to weld, I just hit the foot pedal, activate it, weld, and when I get to the end and I want to finish up and have, you know, my argon shield at the end of the weld, I just press the button again. I've played with it a little bit, just getting used to how the pedal works and that sort of thing, and so I think I'm ready to start doing some welding of some tubing and round welds. The other thing I'd like to show is that this is only a 4-inch platform that this comes with, but I also have a 8-inch that I got. This is actually a faceplate for a wood lathe that I found on eBay for like 25 bucks. And because this has a hole down the center with a Morse taper, I got an adapter for number 2 Morse taper. And this thing locks down, and now you have a much bigger platform. I have an 8-inch welding platform. So for smaller parts, the regular will work just fine, and for larger stuff, I'll be able to use this. For most everything that I do, this will suffice for 90% of my needs. The other thing is that it also makes it nice for being able to turn it horizontal. That's one of the reasons I had to make the base a little bit higher, is because this actually dropped down lower than the base of the rotary table. It also opens you up for a lot more options, having that Morse taper down the center. You can also mount a 3-jaw chuck to this if you wanted to, or a 4-jaw, so that you could dial anything in. The other thing is that I also have a set of Mighty Bites, and for clamping things down, these just slide right into the T-slots. And for when I want to clamp things in, I can put either 4 sides or just 2, depends on how big the flange is. And these are reversible, so I can get different amounts of clamping action on it. They also fit the grooves in the lathe faceplate too. So that will make it pretty handy for being able to hold just about anything I want. But I eventually plan on probably getting a 3-jaw chuck. So if I'm going to be welding pipe together and that sort of thing, I can do joints by holding on the inside of the pipe as well. But that's down the road. For right now, most of everything I do is going to be able to be welded on these two platforms. All right, so I've been getting pretty comfortable with it, so let's go and do some welding, and I'll show you how this thing works.
Alright, so this is actually the first thing that I put on the rotary table so I could try it out. It's the movable part of my hand rest or torch rest for sliding up and down on the vertical rod that mounts on my bench. Alright, so I've got some aluminum tubing tacked up on a flange, and I'm going to try out welding some aluminum. Alright, so you can also see that I'm using the hand rest now to rest my torch on. This makes a huge difference as far as consistency and smoothness and being able to keep my width of my puddle consistent. So here's a close-up. You can see how nice this thing came out. This is my very first time welding aluminum on a rotary positioner, so it's really a game changer for me. It's going to make a big difference in a lot of the quality of my round tubing welds, and I can't wait to build some more stuff with it. Alright, so here's a quick view of the finished product. I think it came out pretty cool. This is something I've wanted for a long time, and I'm pretty happy with how it came out.
Alright, so that's about it for the build of the rotary welding positioner, cordless, Dewalt powered. I hope you enjoyed this video. I hope you got something out of it, and if you have any questions about how to build it or anything that you didn't understand in the video, go ahead, leave a comment and with your question, and I'll be happy to answer it. I try to get to all my comments pretty quick usually. And if you like my content, I would appreciate it if you subscribe, hit the like button. It helps with the algorithm and helps me get seen out there more. If you like it and you want to share it, that's great too. Anyway, I thank you guys for watching, and I'll see you on the next video. All right, thanks.